Hi, everybody. Welcome to section 3.1, where we'll be talking about the first derivative and the behavior of functions. So the learning objectives for this section will be determine intervals in which a function is increasing or decreasing, find the critical values of a function, find relative max and mins of a function, and also absolute max and mins for a function. So let's have a quick warm up and let's actually talk about what we mean for max, mins, increasing, decreasing. Okay, so quick warm up. Try this out if you want, maybe pause the video, but what we want to do for number one is sketch the graph of this function right here. And the easiest way to do that is to find the vertex, right? Find where the bottom or the min or max is um, of this quadratic. So since it's quadratic, we can definitely do that. So here we have the formula for a vertex, right? We have negative b over 2a. And recall that, this is like your A, 6 is your B, and 9 is your C, right? A little bit of algebra refresh. But we calculate this out. So negative B, which is negative 6 over 2 times 1, right? There's that invisible 1 in front of the X. Oops. So what we do now is just finish calculating this out. This becomes, oops, negative 6 over 2, which is just negative 3. Okay, so that's our X component. And now we just need to plug this back into our function to get our Y component for this coordinate point. So we will have f of negative 3 is negative 3 squared plus 6 times negative 3 plus 9. Negative 3. All right, so we simplify this out. This gets 9 minus 18 plus 9, which is then just 0. Okay, so our vertex here is actually the coordinate point negative 3 comma 0. So if I come here and sketch out this graph, it would look something like this. So just draw a quick graph. All right, there's your X and Y axis. Y, X, our arrows. And so, you know, count by ones, 1, 2, 3. Here's negative 3. And then 1, 2, 3, 1, 2, 3. But our point is just negative 3 comma 0. So here you go. Negative 3 comma 0. And the function will just look something like that. Right? We don't have to do all the rest. But we do know it's a quadratic, so it will look something like that. Okay, so that's a sketch of this quadratic. All we need to do is find the vertex. So let's go ahead and check out number 2. Find x where the derivative equals 0. So what it means by this is I need to find the derivative and set it equal to 0 and then solve for x. So let's do that right now. So f of x equals x squared plus 6x plus 9. And I need to take the derivative of that. That would just be 2x plus 6. And then I need to set equal to 0 and solve for x. So 2x plus 6 equals 0. Move the 6 over, so it's negative 6 divided by 2, so I get negative 3. Okay, so let's look at that. So when I set the derivative equal to 0 and solve, right, this is when our derivative equals 0, I get the same exact thing as our vertex, our minimum, right? So that's kind of strange, right? So let's go ahead and look at number 3. Is the vertex at max or minimum? Maybe I just kind of hinted that out already, but since the negative 3 is at the bottom, it's the absolute smallest this function can be. This thing is going to be a minimum. And also the way you could think about this is we're kind of going down here, we're like decreasing, and we're going up here, increasing. So since we're decreasing and then increasing at negative 3, then -3 comma 0, then this thing is a minimum. Okay. Likewise, if it was increasing and decreasing, this thing would be a max. Okay. Just a little review of a max and min. But we do have this part here where when we set it equal to 0, it's the same thing as our vertex. So let's go ahead and branch off on that. So increasing, decreasing. If the first derivative is greater than 0 on an interval, then that means f is increasing. And if the derivative is greater than 0 on an interval, then that means it is decreasing. Okay. So we have these two definitions now, right? So determine the intervals on which the function of the graph is increasing or decreasing. So we just have this graph right here. So the first thing to do is find the mins and maxes of this graph. And what does this mean? These mins and maxes are where the derivative equals 0, just like we saw above with our vertexes. So where the derivative equals 0. And this means the derivative has no slope there. Okay, meaning like a flat line. So at these points, these mins or maxes, this is where there is a change in increase and decrease. Okay. So I want to find these mins and maxes. We don't have to calculate anything. What we can do is just look at this graph and see where our mins or maxes are. So I can see right away that this is a min, right? That's a min. All right, and this is what I'm talking about with the flat line. Like there's no slope there. Is there a slope when you're walking straight on a path? No, slope's only when you're going uphill or downhill. So here at this max for min, there's no slope with this tangent line. Let's keep looking at other ones. So here's another one here, but this is actually a max. So I'll say min, max, and then one last min right here. Okay, so I'll say like there's a min at x equals 1, right? And x equals 4. And there's a max at x equals 3. Okay. So when we write increase, decrease, we talk about our x values on an interval. So the way you would write this is increase our interval we're increasing from is, if we look at the graph, increasing is when we are going up, right? Going up. So if I look at the graph, I'm not going up here. I'm actually going down here, right? Reading it like left to right. I'm actually going down here. So when I'm going up is from 1 to 3. I'm going up that hill right there. So increasing on that interval, 1 to 3. Where else am I increasing, right? I'm not increasing here. I'm decreasing there. I already said I'm increasing here. Looks like I'm decreasing there. Okay, I'm increasing from 4 to all the way to infinity. So this would be increasing on 1 to 3 and 4 to infinity. Open, and you can leave it parentheses. You don't have to worry about hard brackets or anything. Okay, and decreasing, we kind of touched on these a little bit, right? I'm decreasing. Looks like I'm following down here, I'm decreasing there. I'm coming from negative infinity because negative infinity is that way. All those x values that way. So I'm decreasing from negative infinity to 1. That's where my decrease is stopping. To 1. And I'm decreasing only slightly from 3 to 4. All right, just a little downhill there. And 3 to 4. Okay, so that is my intervals of increase or decrease. Okay, so that's a little brief introduction to increase, decrease, max and mins graphically. So let's go ahead and move forward with this, and I'll see you next time. Thank you.